I'm going to use a simulation tool called Packet Tracer, developed by Cisco Systems, and this is going to be used to simulate the building of our network for the Small Office Home Office unit. You can see on the outline here we've got top corner, we have our home office. We have the WRS, which is our wireless router switch, a tablet device, a home laptop which will be connected via wireless, a home desktop which will be wired, inkjet printer, and a separate modem. Now this blue line is a serial connection that indicates that that modem is connected to the internet, which is represented by a cloud. Generally, access to the internet is going to be through your ISP, your internet service provider, and they will give you the details that you will need to configure that connection. Down the bottom left hand corner we have our central office. Now this is outside the requirements of your small office home office network, but it's just good for you to be able to see that the wider wide area networks and LANs are interconnected over the internet. So at our central office we have a router, a gateway router, so that's the one that has access to the internet. We have a server, central server, which would have web services running on it and is accessible to the internet. We've got some internal routers, switches, and end devices, computers connected to this switch. Where you see one computer connected to a switch, it's just representative of any device that can be connected to that switch device. Could be 24 port switch, therefore there could be up to 24 computers connected to it. These different routers may represent different buildings or sections of a large office. Going across and looking at our branch office, you can see the branch has a gateway router R4 that also has connection to the internet, but has a dedicated connection to central office. Now this is not across the public intranet, it's usually a leased line provided through a telco, and it gives them intranet access to the main office. The branch office would be smaller than your central office. You've got a simple switch with a server, printer, IP phones and computers. It also shows a separate wireless access point to be used for visiting laptops and smartphones. Okay, I will just zoom in to our small office home office and let's look at configuring this. Now, looking at Packet Tracer, looking around the outside edges, the menus for the software, down the bottom we have all the devices that we can add to our network, and we'll use those as we go through. So let's have a look. The first thing we should do is take our internet router out of the box and plug it in. So the steps that I'm taking here to configure this setup would be the same as you would basically put on your installation plan to plan how you're going to connect this small office home office together. Now we can all see, if you consider this based on the Heavy Wheels mechanical scenario, they already have a modem and internet access to an internet service provider. So that's indicated here. We've got our modem. In this case it could be, it is ADSL. Heavy Wheels have already told you that they have an ADSL modem and connection. This modem, the blue line, then would represent our phone line, which is plugged into the modem, and at the other end is connected to our ISP, which gives us access to the internet. So on the inside of our modem, the first thing that's going to connect to our modem internally is our router. This symbol here in Cisco symbol just represents a router, and the two antennas that it has indicates that it has an internal access point as well, wireless or Wi-Fi access point as well. The WRS would stand for Wi-Fi, router and switch. If I click on that device, it shows me some basic settings, default settings. So on this config tab, we can look at the configuration. Internet is our connection to the modem, and we can put in here the information that's provided by our ISP, our internet service provider. DHCP would indicate that our service provider is allocating an IP address. That may be the case, but more than likely your service provider will be using PPPoE, point-to-point protocol, and you'll see when I check that box we are asked to enter a username and password. So depending on who you're with, it might be a standard username at bigpond.net and the password that your service provider has given you. The IP addresses in here are greyed out. You won't be able to change them, but once you connect to your ISP, they will fill in to reflect the information that you've been given. At this point, they're filled in for this scenario network, and I'll need to leave that back on DHCP for the purposes of this exercise, because this modem router is already configured to connect to the internet. Again, that is information that would change depending on the service provider that you connect with. So let's go and have a look down the configuration. We'll click on the LAN settings, which is our local area network, and we can see the default IP address of our router is 192.168.0.1. This is a non-routable IP addressing scheme. It's a special reserved address used for internal local area networks and is not routable across the internet. The subnet mask is very important. The 255.255.255 indicates that the first 3 octets of this IP address represent the network address. The 4th octet is 0 in the subnet mask, and that indicates that the last octet must be unique within this network, and every device must have a unique IP address. The range of addresses can go for allocatable addresses can go from 0 to 255. You can see that .1 has been allocated to our router. So generally the first addressable IP is our router. So we can connect up to 254 devices to this router according to this network addressing scheme. I'll click down on the config to our wireless configuration, and you can see the default settings. The SSID has already been set to home office. This is where you would configure it for your client. There's a channel here 1, which is default. Authentication, the base authentication selected is WPA2 PSK with PSK. The passphrase for this network at the moment is home office. Encryption on this network is AES. So you see your selection would be WPA2 with AES encryption. Now this basic configuration tab just tells us how the configuration is looking. If we click on the GUI tab, Graphical User Interface, this is what you would see if you looked at the configuration screen of the router. Now I'll close this window because generally if we've got this router on our network, we don't have a monitor on it. We can't get in to access that interface. So we need to have at least one wired computer connected to the router. That way we can use that wired net connection to communicate with the router, access the admin screen and configure the administrative settings on the router. If I go in and have a look at the GUI screen at the moment, this is a standard screen that you would find on Linksys routers, which are a subsidiary of Cisco Networking Academy. We're on our Setup tab, looking at our internet setup, network setup. We have a wireless tab to access our wireless setup, etc. Closing that. I'm going to start connecting some devices. I'm going to connect the router. The first thing you would do is plug it into power, and the second thing you would do is connect it to our modem. So down the bottom of our packet tracer, we're going to go to the connections, which is the little zigzag. And when I click on that, I have lots of different connections. You'll see the blue, coaxial, the dotted one is telephone, and our single black line down here is copper straight through. So that's a patch cable, Ethernet patch cable. I'm going to click on that, and I'm going to, you'll see my mouse changes to a plug. I'm going to click on the modem, and my option is to plug that Ethernet into port 1. There's only one port on the modem. I've connected to the modem, so I'm now going to click on the router, and you'll see typical rear end of a router. You have an internet, a WAN connection, and you have 4 Ethernet ports. This is an Ethernet connection to the modem, but it needs to go into the internet port because that's the outgoing port to our modem and onto our internet. So I'll connect that. Now you'll see the green dots. If the green dots are green, basically then you've got that level 1 access, layer 1 access, which is your physical access. So 1, you've got a medium connection, which is Ethernet, and 2, you've got some data going backwards and forwards through that cable. Now that data is just the basic Ethernet control messages going backwards and forwards between port switches. If you looked on the back of that router, you would see the switch ports flashing, which indicates that there's some messages going backwards and forwards between those 2 ports. Okay, the next thing you would do to connect this network up is to use your home desktop and Ethernet cable connect to your router. Remember, it's no sense trying to configure our router through a tablet or a home laptop if we're not sure that we even have a connection, a Wi-Fi connection. So we always should use a cable connection. So again, I need to go down to my connections, pick up another, click again on the copper straight through. I'm going to plug it into my home desktop, click on that. I have a choice of RS-232, which we're not using, and fast Ethernet port. So I plug my cable into my Ethernet port on the desktop, and then I will go over and click on the router, and you'll see that there's 4 Ethernet ports available. So I'll click on port 1, and that cable connects. See, there's an orange dot That means that there's some base communication going backwards and forwards between these switch ports. Now what is happening here? By default, our router has DHCP enabled. Out of the box, that's the way they work. The home desktop computer was not connected to any network. As soon as we connected, you'll see those dots have gone green now. As soon as we connected an Ethernet port to one switch and then connected it to another switch, as soon as there is a layer 1 electrical connection between those two ports, the home desktop computer realizes that it's connected to a network, and it will look by default for a DHCP server. So the home network computer is looking for an IP address. It sends a signal down the Ethernet to the wireless router and asks for an IP address. The router sends it one. Once they have communicating backwards and forwards, that's when you get those green dots, which means both devices are communicating on the network. So now we're going to click on the home desktop, and we're actually going to open the screen, and we're going to connect to our router. Now let's just have a look at the home desktop. On the config screen, this is really just gives us, if we click on fast Ethernet port, this is the network interface card. The port is on, port status is on. We have a MAC address for that Ethernet network interface card. The configuration is DHCP. You can see we've already picked up an IP address from this network, 192.168.0.100. So our router has allocated a unique address of 100 to the home desktop computer. The subnet mask must be the same as what's on the router to indicate that they're using the same network. There's an IPv6 configuration that we're not going to worry about at this stage. So from my home desktop screen, I can now go to the desktop tab. Now this doesn't quite look like a standard Windows desktop, but it gives you access to the most common applications that you might want in this simulation environment. So the first thing we're going to do is open a command prompt, because part of checking that our network is working is to make sure that each device has a connection, a valid IP address, and can communicate. So the first thing we do at our command prompt is type in ipconfig and press enter. IP configuration is a tool that just gives you the configuration of this network interface card of your computer. So you can see we've got a fast Ethernet 0 connection, which is our default port. It lists the IP address, .100. It lists the subnet mask. It also tells us our default gateway. Now we've already looked at our router, and we know that its address is 192.168.0.1, and we know that we have a communication then to our router. This router is called a gateway because it's actually the router that gives us access out of our own local area network. So default gateway, if devices inside our LAN are trying to communicate and they know that they need to communicate outside of our LAN onto the internet, then they send their packets to the default gateway. Now, the next troubleshooting tool, we should be able to ping our own address. Type in ping, P-I-N-G, then the space 192.168.0.100, press enter, and we should get a communication. This is testing our own network interface card on the computer that you are sitting on. It's called a loopback test because it tests in and out of our own network. We could also ping a loopback address. This is a special address. Anytime you do a ping to 127.0.0.1, you are pinging your own interface. And again, what we're getting is 4 bytes are sent, and we're getting 4 replies back from that interface. So that indicates that we have an active interface. So we'll close our command prompt. We know that we now are connected to the router. We're going to open our web browser, and we're going to follow the standard and we're going to type in the IP address of a device on our network and press enter. Okay, this is the address of our router. The admin, the local default login to our router, to this particular model router, is admin for the username and admin for the password. For security, of course, the first thing you're going to do is change that password. The default IP address for this model, the default username and the default password, this information is all freely available on the internet. So if you don't secure it, then anyone could come in, plug into your router and get access to your network. I'll click OK and I'll log in. Now this is the same interface that we saw when we looked at the router, but in a network we couldn't. The only way we can access this is from a computer on the network. So again, we'll go through the screen here and have a look at the different configurations. We're on the setup screen. So the first one here is our internet setup. It's already configured to communicate on the internet, and it's using DHCP, which we looked at before, and the connections are already set. So at this stage we won't change that, but bearing in mind again, if you're using an ISP through ADSL, then you're going to probably be using point-to-point protocol, and you'll need a username and password to access the service. Scrolling down, the next part of our screen is our network setup. So network is our LAN, our local area network, and we can see here the IP address set for this router, 192.168.0.1. Now that is the default. Again, it's information that's freely available over the internet. Another level of security would be to change the default IP address. We have any option as long as the first, remember the fourth octet .1 must be unique within our network, but the 192.168.0 we could change anywhere here, the third octet to 250 to anything, and that would make our network unique. It's hard for people to access your network if they don't know an IP address. So we're going to change that to 10 and change the defaults. The subnet mask, there's lots of different options. We're using a standard Class C subnet mask, where the first 3 octets define the network address, and the last octet is the host address, which is every end device in your network. Next setting down, we're looking DHCP server. So do we have DHCP enabled on this network? So by default, out of the box, DHCP is enabled. That is why when we connected our home desktop, we were allocated an IP address and we could communicate with the router. If that is not happening, if you're not connecting to your router, then maybe it's because DHCP is not happening. You can see the default range is the first IP address that's being allocated through DHCP starts at 100, which is why our home desktop got an address of 100. There's a setting in here for the maximum number of allocatable IP addresses is 50. Now, our Heavy Wheels office is never going to have 50 computers. So again, we could limit the number of addresses available through DHCP to again tighten down that security. I'll leave the default settings for now. The IP address range, we could expect our clients, all our client computers, to be in the range of .100 to .149. There's a lot of other settings here, but these are the basic ones that you would configure. Okay, so that is our basic physical connection and our configuration. I'll just go to the end of the screen to the status tab, which shows us the current status of our network. Gives us router information, the version, the MAC address of the router. It also gives us information about our internet. This is telling me that we're DHCP, we've been allocated an IP address through the internet, a subnet mask, a default gateway, etc. Now again, this won't mean anything to you, but this allows us to access the internet, and that will be different depending on your ISP. Status of the router. On the sub-tab, status of the local network, we'll click on. The local network, it gives us the MAC address of our local network. Again, the router IP address, the DHCP server information. The DHCP client table should show us any clients that are connected to our network using DHCP. It does tell us there's one. It doesn't have a computer name, that's missing. We should fix that on the computer. It's telling us interface through the LAN, Ethernet, the IP address, the MAC address. I'll close that window. On the status tab, we'll go and look at the status of the wireless network. We have a MAC address of the wireless network. So remember, it's still an interface. It's a network interface card. It has a MAC address, even though the media for communication is wireless signal. We already know the SSID. We know the security, and we've got broadcast turned on. This is the status, but let's go to where we can actually configure our home wireless. So along the top, we'll just go back to our main wireless security wireless tab, and here's our basic wireless settings. The network mode by default is mixed. If we click the down triangle, you can see that this is the different wireless standards. Wireless is 802.11, and there's different standards within that main standard. The current one at the moment is Wireless N, is the most common one that you'll find. Wireless B and G are earlier versions, and used, as you know from your theory, they use different technologies to connect, different speeds. If you knew that all your N devices were modern and had Wireless N, then you could change Wireless N only. Again, it restricts the different devices that can connect to your network, and there's less overhead in that translation of signal. But if you do know that you've got a mix of devices, old computers, maybe older tablets, etc., then you might want to leave it at mixed. The network name, the SSID of the network, is the name of the wireless service set identifier. Now this has defaulted to the name of our router. So it's something that you could leave the same or you could change it depending on your client. So anyone looking for this wireless network would be seeing Home Office. We're just going to look at the SSID broadcast is enabled. Broadcast means that we are broadcasting your SSID across through the air. So if you come along with your mobile phone or smart device or any wireless enabled device and open the wireless and search for available networks, this SSID is being broadcast. So you would see a wireless network called Home Office, and that would allow you to connect to it as long as you have the security key. If we disabled the broadcast, that means it wouldn't be seen in available networks. So if anyone was randomly walking past our office, they wouldn't see that network available. So it's a lot harder to connect to a network that you can't see. So security wise, it's good to disable your broadcast. We'll leave it enabled for now because it makes it easier to configure our devices to join to that network. Up onto the sub tab for wireless, I'll just go to the wireless security tab, and here's where we set our security. Very important that we don't have an open network. Click our down triangle and see what's available. Through your theory, you should all know that WEP is older technology and not very secure, but you may need to choose it depending on the technology that you've got that have to connect to your network. Ideally, you would upgrade the host devices so that they're using WPA2. Enterprise, WPA2 Enterprise is only on server networks where you're actually authenticating with the server with your username and password, not with the router itself. So we'll stick to personal because we don't have an enterprise setup. Encryption, AES or TKIP, the default AES. The passphrase, this is the password to access our wireless network. So of course it's not a good idea that that is the same as the SSID. We're giving away the password. So of course your next important for security to set a very secure passphrase should be at least 8 characters, a range of capitals, lowercase, numbers and characters, etc. I'll leave that one for default. Looking at the next tab, wireless MAC filter. This is another way to secure your wireless network, is to secure it and filter only the MAC addresses that you specify. Remember, your MAC address is the address of the physical network interface card on your device, and you can specifically type that in so that whether they have the password or not, if they don't have a MAC address on this list, they cannot access your network. Very useful if you've got only a small number of computers, but it's not the best security. But don't forget, adding all these security techniques together will make your network harder to get into. If we enable the wireless MAC filter and look at the client list, permit, and look at the client list, we don't currently have a client list available because we don't actually have anyone connected via wireless. So we'll come back to that. Okay, we'll have a look at the security tab, and we'll leave these settings default for now. Access restrictions, again, this is we can have access policy that, and I again apply more permissions to different computers on our network. We could specify, for example, the days that devices can connect, specific times. If your client computers can only connect between 8 and 5 on a weekday, then you're securing your network even more, that someone can't sneak in on a weekend and try and connect. You can block specific URLs, websites. We could block www.facebook.com if we wanted to. We could block by keyword. So we might want to put words in here that actually block websites. We can also block by applications. Now these applications should be familiar to you. They're your standard different protocols for different applications, part of your TCP/IP protocol suite. HTTP port 80 is your web protocol. HTTPS is the secure web protocol. Make sure you see HTTPS in your web browser if you're doing internet banking. We've talked about FTP, file transfer protocol. POP3 is an email protocol to receive our emails, and SMTP, simple message transfer protocol, is the protocol that we send emails. If we don't want our computers inside our network to be able to connect to FTP and transfer files in and out of our network, then we can block that protocol. So again, another way of securing your network, but definitely a little bit about outside of what you're doing with this unit. We'll go across the next tab at the top, Applications and Gaming, where single port forwarding is listed on the HSC list of terms that you should understand. Single port forwarding allows a specific external access from the internet to come into your router, and your router will forward that request to a computer on your network. An example might be if you've got a web server, you're hosting your own web service website, and people would need to access your website from the internet. It's no sense having a website if you can't get to it from the internet. So you would allow port forwarding. So the application name would be HTTP because it's standard website. You would put down the IP address of your external port, which is allocated to you by your ISP, the internal port of the server that you're allowing that request to go to, the computer, the web server, the protocol, HTTP, and you would type in the IP address of your web server. And you would tick to enable that. That means if any web request comes to your external IP address, you're allowing it in, but you're telling it can only go to the web server. So your other devices on your internal network are still secure. On our sub menu, the other one that some of you might be familiar with it is the DMZ, Demilitarized Zone, often used for gaming. Again, you would enable it to a specific IP address on your network, and you would allow requests in from outside of the network to go to that computer. Some gaming sites require that. The next main tab, Administration. Here's where we change the router password. At the moment it's admin, so you would change it here to secure your router from someone getting in and making the changes. Web access and remote access allows you admin to access your router from out on the internet. We don't need to worry about that at this stage. The important one down here is backing up. If we've spent a lot of time configuring this router, typing in MAC addresses, putting in access policies, then we don't want to lose all those settings. Like any data, you should back it up. back up the configurations, we use the saved file and we would save it to our desktop, somewhere to a secure location. Therefore, if anything happened, if this router had an accident, fell off the bench or got destroyed, all we would have to do is replace it with a new device, restore the configurations from our backup file, and we would be up and running with little disruption to our users. Right, we've looked around the interface. Our wireless settings are already set, and we'll close out of this. I'll close our home desktop. So now our home desktop is connected to the router and we've configured the router settings. Next thing we do is we might connect another device. So our inkjet printer is, in this case, is cable connected. If I click on the inkjet printer, it brings up a bit of a configuration screen. They're fairly basic. It's got a fast Ethernet port that's turned on. It's set for a static IP configuration, which is generally normal for devices that don't move around your network. So I can connect a cable to this, but it's not going to be able to communicate on the network until I actually type in a static IP address. So we know that in order to communicate with other devices on our network, we need to have 192.168.0 as our network address, and we need to allocate it a unique host address. We know that DHCP is allocating from .100 to .149, so as long as we give it an IP address outside of that, then it will be able to communicate on a network. Now remember, I changed our router network to .10 network, and we'll give it the printer the address of 10. So you need to be writing these down as you configure them. We must put a subnet mask in, and you'll see if I've clicked in there, it's put a standard class C subnet mask in by default. Again, the 255.255.255 indicates that 192.168.10 is the network address, and every device must have those same 3 octets with the unique host address to be able to communicate. So that's all we can do for our configuration of our inkjet interface. Now, because this is configurable, you'll find on the physical printer you would have a menu and you would be able to configure that IP address. So I'll close that screen, and I better connect our inkjet with our cable. So I'll click down on our Ethernet, click on the inkjet printer, plug it into the port, go to our switch and use one of the 3 remaining Ethernet ports. Again, our little orange dot is indicating that that router is communicating with the inkjet. And I'm just going to double check the IP address of the router, the LAN, because we didn't change the IP address to 10. We kept it at 0. So the fact that this little red orange light is stayed on 0 means that it's green now. Okay, our printer should be connected to our network. The next thing we can do is, we can't test in this simulated environment printing, but normally the first thing we would do from this point is at the printer menu we would print a test page. Physically from the device, make sure that the printer is working. There's paper loaded, there's ink loaded, and there's power, and it's actually can print a test page. The second thing we can do is from the home desktop we can print. We need to install a printer using the discs provided, and then we can print a test page from the printer settings page that tests that we can send a print job from our desktop through our router to our printer, and we can print it as a test page across the network. The third testing for your printer is to print from an application on your home desktop. So you might open Microsoft Word, type in a few words and hit print, and that page should then come out on your printer. We can test that inkjet is on our network. We can send it a ping. So from our home desktop, open a command prompt, and we're going to ping the printer .0.10. That's the static IP address I allocated it, and we've got a reply. Therefore our printer, our inkjet printer, can communicate across our internet. So don't forget to test and make sure that every device that you connect, do it one at a time. Connect it, configure it, test it, make sure it is working before you move on to the next device. No sense plugging everything in, finding something doesn't work and not knowing where to start. So what are we going to connect now? Let's look at our home laptop. This is going to be connecting via Wi-Fi. Now we know from the settings on our router that Wi-Fi is enabled, so let's go to our home laptop and see what we need to do to configure this. On our basic config screen, I'll go to the wireless, looking at our wireless network interface card and seeing what we need to do here to configure it. We'll just go to the desktop . Okay, so looking at accessing the wireless network card on the laptop, the port status, so this is our wireless port, make sure that it's turned on. Quite often on laptops there will be a physical connection where you can turn off your Wi-Fi signal. On my HP laptop it's a little touch, a light with a little touch across it that you can touch it, green for on, orange for disabled. So make sure that that NIC or port is actually turned on physically. It has a MAC address. The SSID has been entered already. So someone has actually already configured the home office that's the one we want to connect to. Authentication, we need to put a password in. We won't be able to connect until we authenticate. Currently it's disabled. Remember what was configured on the router, WPA2 with PSK, and the passphrase is home office. Again, not very secure, but for the purpose of this prototype that will be adequate. Check the configuration type is the same as on the router. Interesting at the moment, the IP configuration screen, because we haven't actually connected to the router yet, we have DHCP enabled, which means as soon as we electronically connect to the router through that Wi-Fi signal, that home laptop will ask a DHCP server for an IP address. Remember, it can't communicate on the network until it has an address on this network allocated from the router. An interesting point to note here is the current IP configuration of this laptop is 169. Oh, it's just changed. Because we've put the passkey in, you'll see on the image that there's wireless signals. So those devices have communicated and connected. The laptop has received a DHCP an address via DHCP, and look at the address that we've been allocated, 192.168.0.101, and we would expect to get that address. It's DHCP. Our home desktop received the first IP address, .100. Our home laptop has received the second IP address, .101. Remember, our printer was static and we allocated it .10. Now, before that changed, the IP address was 169.254.0. something. That's very important that you remember that range. What that means is that's auto config. Windows auto config, which means when that laptop turned on, it couldn't find, even though DHCP is enabled, it couldn't find a DHCP server. And so it configured its own IP address. That is always a 169.254 address. Okay, now we have connected. Let's check our own configuration. So we'll open a command prompt, type in ipconfig, and look at our own configuration. We don't see an Ethernet connection here because there's nothing plugged in on Ethernet and we're not using it. So we see wireless 0 connection, the default port. We can see an IP address 192.168.0.101. We can see the subnet mask, and we can also see our default gateway .1. So now our home laptop is able to communicate on this network. Because it knows the default gateway, it should also be able to communicate outside of this network. So let's try a ping test. Let's again ping our router. We know that we're going to get a reply because our router just gave us an IP address. But it's good to get in the habit of pinging around your network, because when you need to troubleshoot, then you have an idea of how all this operates and how you can use it to test and troubleshoot. So let's just maybe ping our printer, see if we might be able to print. And our printer's sending a reply back. We could also ping the home desktop. And we would expect to get a reply back from that. Good. Now if we knew an IP address out on the internet, we could also ping that as well. I'll close our command window. Our laptop is up and running, so let's connect our tablet. Let's have a look. Click on the interface for our tablet. Go to the wireless settings. Again, our wireless is turned off. We know if we've got smartphones or iPads or tablets that you can actually turn your Wi-Fi signal off. Make sure it's turned on. Make sure we have the correct SSID for the network we're looking to connect to. Make sure we have the correct authentication and passkey in. You'll see it currently. The IP configuration is a 169.254 address because this device has auto configured. But once this device connects, we've put in all the detail, we've turned the port on, DHCP is configured, and you'll see now that we've been allocated an IP address from the router. And again, we would expect to receive .102 because it's the next available address in the DHCP scope. So our tablet is now connected to our network. Let's go to the desktop. This must be a Windows tablet because we've got a command prompt, a typical looking Windows command prompt, and we can ping. Let's ping ourselves. Yep, this tells us that our wireless interface is turned on and is active, and is returning that signal. We can ping our default gateway. Excellent. So we know our networks communicating. We can ping our printer. Okay, I'll close this screen. All the devices on our network are communicating. You can see the symbols, you can see all the configurations, so you can get the idea of how we can use Packet Tracer to simulate our network, especially in more advanced detailed networks. This gives you a way of designing it and checking that they're going to work. The only thing we haven't checked is that we can access the internet. Now we know we have an active network connection. We know that our modem is DHCP, so it's getting an IP address from something across our network. Central server here is a web server on that network, and the IP address is this 10.10.10.1. Now for everything on this internet, across the internet, all routers are connected and running and all interfaces are up, then we should be able to access a web page across the internet. So I'm going to open the tablet, go to the desktop, I'm going to open a web browser, and I'm going to type in the address of that server across the internet. Type in let's just close that for a minute. Now I'll just go to, we've got our home office network working. We need to test our access to the internet. Now generally we could just open a web browser and type in www.google.com.au. What happens then is that request goes to our default gateway. Our default gateway knows that that request must go out to the internet, so it sends it to the next router. That's called the next hop. Sends it to the next router outside of its own network, and that will continue until a router at some point finds the Google page and sends it back to our tablet to display that page in our web browser. How that happens is DNS, Domain Name System. Of course, we can't remember IP addresses of every computer across the internet, but we can remember web addresses. So the domain name system was established so that we could just type in google.com.au, and the DNS system would then check its indexes. All the routers on the internet have a DNS index, and it will look up google.com.au and return the number of the IP address of that server, so that the computers on the internet know how to communicate using numbers, but it makes it easy for us. We only need to use domain names. So I'll just again open the interface of the router. Tells us our default gateway address. Remember, a default gateway is a way of getting out of your own network. So for each of our devices on our local network, their default gateway is the router, but their default gateway is the internal IP address of the router, 192.168.0.1. This external interface that connects to the modem is just a bridge. The modem, remember, just changes the signal. So it changes the signal from digital on our router to analog to go across the phone lines, ADSL. So that modem doesn't have an IP address. The external IP address of our WRS router is the one that's allocated to it by our ISP, Internet Service Provider. And we can get that internet, and it's 223.0.0.1. .2 is the IP address of our router interface. .1 is its default gateway. So every router identifies that the next router along the line is its own default gateway. So again, from inside our network, we can ping those addresses. DNS server is 8.8.8.8, so somewhere out there on the internet is a server with an IP address of that, holds a domain name system index on it. So let's test. Again, this is a little bit over the requirements of your SOHO. You do need to get to your ISP. So we'll open our home desktop, we'll open a command prompt, and we'll try pinging. Remember, we can ping the internal interface of our router, which is the LAN interface. Then we can ping the external interface of our router, which is the interface, the IP address that we received from our ISP. And that one is 223.0.0.2. And we're getting a reply from that. So remember, ping works at that layer 2 network interface layer, and we're getting reply back that that network interface is turned on, it's active, and it has an IP address. Now I'm also going to ping the default gateway of the external interface. Do you remember what that was? .1. Which would be the address of our ISP in this case, because its address is .1, it's allocated .2 to our interface, and those two are communicating. So that is this communication between WRS and between our router on the internet. Let's just try a ping to that DNS server. The first packet timed out, but the next 3 packets sent, remember, ping sends 4 packets. The first one timed out, but the others arrived. What that means is that the very first time that you ping a server, it takes longer for that request for that server to be found and for that request to be sent back to us. But once we've done that, every router between those two end devices remembers that address, so the next 3 pings come back quicker. If I try that again, straight away all 4 pings will come back quicker because they've retained that information in memory. So this tells us that we can ping our ISP, which means we're getting out to the internet. We're pinging a DNS server, which is somewhere out on the internet, therefore we can get outside of our own network. So that's the most troubleshooting you would need to do for your SOHO. If you've got a client that says, I can't get a website up, and so they're typing in a web address and it comes back with error 404, page not found. Now you know how to troubleshoot that. There's so many different ways, protocols and things involved, and interfaces between that computer and that website out on the internet. So you know you would open your troubleshooting tools. If I ping the central server out on our central office. That will test that I can ping the server at that office. The first one's timed out, but we do have replies back. And if I send that again, I'll get 4 replies back. So that indicates at central server I have a connection across the internet to that one. So ping, of course, tests a valid end-to-end connection between one device and another device across a network. But sometimes you might have a ping to a different server, but you still can't get their web address up. So we can actually ping a name. We can actually ping an IP address, a URL, for a host that we know is up and running. So we actually type in the URL of that central server. And I know the address because I looked it up. I went to the server and looked up that information. So this central server is a web server. It's hosting web pages and it's listening on port 80 for the protocol HTTP, and it's listening on that port. If we type in http://, you know now that that's the protocol, that that's the application that we want to talk to. centralserver.pt.pta is the domain name, and I'll press enter and it can't find it. So ping is not working. Doesn't mean that server's not working, it just means that that DNS name resolution is not working or not configured on this network. I'll close that. What I'll do is open a web browser and I'll type in the URL here. So we know the web address of that central server website. pt.pta, and I'll press enter. And now I'm on a web browser on my home desktop computer. I'm putting in a web address of a computer out on the internet in our simulation, and I'm getting a response back. So I'm actually getting a web page back. You have successfully accessed the home page for Central Server. So that HTTP request has gone out across the internet. It's been picked up by Central Server and they've sent back the web page to my home desktop computer. And I know that that's working. So we've tested our network, we've joined all our devices together, we've tested in great detail all our interfaces, we've used ping to test all other devices within our network, we've tested the internal interface of our router, we've tested the external interface of our router, and we've been able to ping and open a web page of an external server. So that's about the limit of the test, and we know that this network is working. The final test for any network is to document the network. A simple form of documenting, I'll just bring my Word document into the screen. Scroll up to the top. I've got configuring the network. This is basically my installation, roughly an installation plan. It lists each device. What I'm going to do, I'm going to plug it in, I'm going to look on the configuration, I'm going to check all those configurations. Okay, So it lists what I've got to do. Internet, I'm going to connect to the modem, I'm going to configure the settings for the modem, etc. The inkjet printer. Physical, I'm going to connect my cable. Configuration, I'm going to put in a static IP address. My home desktop. Physical, I'm going to connect the Ethernet cable. Logical, the configuration, I'm going to check the Ethernet settings and make sure DHCP picks up an IP address. My home laptop. The physical configuration, I can't plug in a cable, but I do need to make sure that the wireless settings are turned on and configured suitably for my home network. My tablet, same thing. I need to make sure that the interface is turned on and the configurations are suitable for that home network. Testing the network. This is my list of everything that I need to test to make sure that my network is complete. Physical network connections in the interface. In this simulation, all interfaces should be green. On your physical, actual SOHO network, you should be able to see Ethernet lights blinking and flashing. You should be able to see on your wireless screen, you should be able to see the little wireless symbol that shows you the number of bars that you've got, or how close you are to your Wi-Fi, how strong the signal is. So that's you should be able to check all that physically on your network. From command prompt, again, you should be able to check ipconfig on every device to check the actual interface on the device, and then you should be able to ping across your network devices. And each ping to a different area will test something different. And then from your home desktop, you should be able to open a web browser, and from there you should be able to go to a URL on an external web host. So pretty much that's how you test your small office home office network. The final thing you need to do is document your network. So this whole document is part of your documentation, the installation and configuration settings, the testing settings and results, and this table. A good table to summarize all your devices. This would include device names, the connection type, how each device connects to your network, Ethernet or wireless, the IPv4 address for each device. You can see I've got the WAN address in here, the LAN address. I've indicated on here where this device is static. That IP address is static, whereas here I've just got an X in the 4th octet and DHCP. So that indicates that the actual Ethernet address, IP address on this one might change as it gets a different DHCP address. I've also got the IP address of the central server down here, so I could test that. Security and comments, you're going to include specific security to secure your network. For example, on your user computers, you would have a user login. On your router, you need to have an admin login, and you need to have a security and encryption, authentication and encryption on your Wi-Fi access point. So that concludes the discussion of our heavy wheels of connecting a small office home office network and configuring, testing, documenting in this simulated environment. You use the information you've heard here to finish off the activities for your SOHO practical. Thank you.